Hello and welcome back. So let's do one real quick video this time around. So what I'm going to do is I'm gonna do reverse polarity protection. Just I was thinking about it recently. I was looking it up online, and there are a few options that are normally used for this. Now, there is a question, how do you get your pedal to, how do you mess up your power supply for your pedal? But that's a different matter, I worked in line of business where, if something can go wrong, will go wrong, so you should be probably prepared for any eventuality. So what I'm going to do, I have here, I'm going to start with a few different approaches. So few most common ones are, using normal diode or Schottky diode, but I'll cover one with the MOSFETs as well. So very common one is when we have a diode like this. So if the correct polarity is plugged in, the diode is on and it conducts, so we power up our pedal. But if there is a reverse polarity here, the diode will be switched off and we won't get, our pedal won't get damaged. Okay, so so this then serves as an open like a switch. There's more to it than that, because obviously there is a voltage drop. So that's why I put here question mark. Is it 9 volts here? So let's have a look. So I just put this load here just so I can do some checking with my multimeter. But let's go through this real quick and see how this works. All right. And for this, I'm using this 1N4001. It's a pretty sturdy diode. It can take a beating. So let's see. I'm just going to do it like this. All right. All right. So I'll just plug in my my multimeter here. So positive end, ground, and let me actually test what my voltage of the battery is, because if it's not new, even if it's new, it has a bit more voltage than 9 volts usually. Let's see, that's what, 903. Yeah, okay, pretty close. 903. So let me just readjust this real quick, and then I'll put it here so I can. So let me plug it in. So this is the correct polarity. This is correct polarity here. So let me plug it in, right? So 852. 852 volts. So that's quite a drop, nearly, what is this? 500 millivolts. So in reality, that is a slightly making your headroom smaller, but how much does it matter it's open for questioning, you know. Depends on the pedal, obviously. If I do reverse polarity, nothing. The diode is switched off. There will be probably some leakage current and stuff like that, but that's not really important. Anyway, this is kind of your pedal is protected. Now, obviously, downside of this is that there is a big drop over this diode. Now, one thing to consider is when you're looking at this, it's not that important for what we are doing. Our pedals normally don't draw lots of current, but you know, just for completeness sake, the current that goes through the diode, it can, you know, it can cause diode to. There is kind of a rating of all these diodes, how much of the current they can take, etc., and how much continuous current and whatnot. As I said, it's not a big deal for us. They won't get warm or anything in this configuration anyway, so it's not a big deal. So another popular option is to use Schottky diode. Okay, so big advantage of Schottky diode is it's pretty much the same approach as with regular silicon diode. It's just the case that, you know, it has a lower voltage drop. So let's see that. So when I plug it in properly, 883. So that's like 200 millivolts of a drop. Here 852. So we gained 300 millivolts here. So, you know, again, if I turn around, there is some slight current through. Again, there's leakage current and reverse current and stuff like that. So that is really in micro. So let me see for this. I don't have a datasheet ready, but it's nothing to be worried about. Now, this is pretty good, right? But in cases where you want to maximize this or minimize the drop, what do? The best solution is to use MOSFET. And for us, it's P-channel MOSFET. It's like what we want to employ. So I have one here. It's a small one. It's TP2104. It's not really power MOSFET or anything. Again, caveat, we don't deal with lots of current, so most likely even the small one like this, a MOSFET like this, will work just fine. So how do we do this? Let's do that now. I'm not going to use Zener diode. Zener diode here is just for protection of the MOSFET, because if too much of a voltage over gate source will destroy it. So normally you put a Zener diode there. But for purpose of this demonstration, I won't be using it, just for simplicity. So I'm just going to put as per schematic here. Get, oops. It's going to go like this, I suppose. What do we have here? This will be my 9 volts. Going to be ground, and I want my load here. Okay. I crammed it in, right? Did I? So, yeah. Maybe I can do this as well. Yay. All right, so that's it. Let me plug the stuff in. All right, the moment of truth. Hey, 902. Wow. Okay. I knew this would happen. Now, you can see that we got the best, the smallest voltage drop. There is going to be some voltage drop. The MOSFET here acts nearly as a resistor, and it will have a few ohm resistance, and it will. So this is very important when you're looking into datasheet, and depends on the current that this will draw. It's important to know how much that is and how much power dissipation is going to be. So, and to keep the MOSFET in its operating range, and we don't destroy it. But for us, again, caveat: low power, low currents, so it's not going to be a big deal. Even a small one like this will work. Now, reverse polarity. That's it. So how this works is, when a reverse polarity, this acts like a switch and it's turned off completely, so there's no current flowing. Again, there will be some. We are talking about nanoamps there, so that's really nothing to speak of. All right, so by far the best, but also the most expensive and the most complicated one, where you have one component here. Here you need three. So there's a fourth one that is commonly seen, and this one here, we have regular diode, but wired up like this. So let me just do that real quick. Now I said here do not use, and I'll explain myself there. Why you shouldn't be using this. Maybe I'm over dramatic about this, but say I'm just gonna do it like this. Where's my load? It's going to be this. Now, obviously, there won't be any voltage drop here. And this is the biggest, let me just plug this in. The biggest advantage of this approach. Okay. So let's do it. So this is correct polarity. Or is it? No, I missed it on the side. So as you can see, there's no voltage drop as you would expect. This one, the diode is turned off, so That's pretty much it. What is interesting is if we switch this around and we put we reverse polarity, now the diode will start conducting. It will be on. So I'm just doing that now. There is a slight drop, but you know, here it's fine, and it's dropping because it's actually getting really hot. What's happening is, and I'll just wait for this to cool down a bit. There's no limit to this current, okay? So as much as the battery can give, and battery is also a tiny bit warm, as much current as the battery can give can flow through this, okay? So if I check now, look at that. This is how much I exhausted my battery. That is mad, isn't it? Battery is a bit recovering now, I think. But the important thing is, this is, okay, this is a big ass diode, relatively speaking, obviously. It can survive 30 amps of current, well, peak current and short-lived. So if you use something smaller, like this, for example, that might cause the diode to destroy the diode. There is no protection after that, because it will be like open circuit here, so you lose all protection. So this is not very good approach. So let's see if I put, for example, and I'm going to destroy my battery, I'm sure it is, but let's see, say I put something smaller, like a signal diode. You wouldn't do that, obviously, but if I done that, something crazy like that, what would happen? Because this one can take way less current and safely, anyway. Let's do this. Let's plug it in. And deliberately, let's do this reverse. What? Did you see that? It is gone. It is gone. It just went up in smoke in a second. So let me show you. So this is reverse protection. Huh? Actually. Yep. See that? That is your protection gone. This went up in smoke so quickly, I did not expect that. Well, I expected to go up in smoke, but it was like real quick. Where is the camera on this? What? All right, so I know this looks dramatic, right? But in reality, there's no limit on what this can, well, there is physical limit, etc. But there's no actual limit on the current flow. So say if you have a normal pedal power, which is 50 milliamps, the question is, would would this diode get destroyed or not? You know, and again, if you use something like this big, it will work. It will survive. So do not use. Yeah, you shouldn't be really using this wiring it this way. Again, it will most likely work. I would. Again, you saw what happened, so decide based on that. So from my perspective, looking how I would approach this, it's either Schottky diode or p-channel MOSFET. That's the way to go. This depends on what you want to achieve. Again, this is probably the easiest one to do. I hope this was interesting. We had everything here. We had drama, we had things exploding. Well, it's over a statement that, but don't you love videos like this, huh? Until next time.